me ask you a question before I forget. I don't know how this deal is going to work going forward. It's not a big deal for y'all, but how many of you have actually done the online evaluation for this class already? Oh, you already have. I'm surprised that many did.
It keeps emailing us.
This is the first, it does?
Yes.
It's the first time they've ever done this online thing, and they told us that you can't, you don't do it in class. I mean, you can, but you can encourage your students to do it, and you can take class time to do it.
Yeah.
I was thinking if I might have y'all do it today as a group. I mean, not as like a group project. But
Yeah.
During class sometime, and like give you extra.
For Orgo Lab, we had to do it before we could take our last quiz. But just from what our TA says, so I'm sure somebody told him that he has to do it.
I'm curious because, it's funny that how many have already done it here. I wonder how it works because you think that it's not like we typically just give you the piece of paper and you do it while you're here. You don't have a choice basically. But you would think that a class that it was, they were just having you go online and do it. That for me personally, I'd probably blow it off.
Oh, I have it.
But the people that, the people that don't like the professor would be the ones that do it.
Yeah.
And so that I know for me it doesn't matter. I mean, I've been here 1,000 years, but I'm thinking like some professors that haven't been tenured yet.
Yeah.
We had like a shitty PA, so we all did it without any reason.
Yeah, I'm curious how that's going to work going forward with some of the people that are trying to make tenure. If they're bad, but I don't,
Right, they're only going to have the bad ones. They're not going to have the good ones.
Of the class. Anyway, that's not y'all.
I don't know. It's only the emails us.
So you want to do that?
Yeah.
Yes.
Okay, I'll give you like 5 extra credit points on the test. We'll do that in the class. Actually, it'll be more like do it while you're here, and then I'll just take attendance, and who's here gets 5 extra credit points.
Is that today?
Today, yeah. Just remind me before.
Yeah, we will.
Okay, the exam, I haven't written it yet. We'll write it this weekend sometime. It's going to be very typical of what the other exams are. The material starts, where does the material start, actually?
Chickens.
Okay. Up till what we covered today. All right, so we're going to focus today on a couple areas. One, the process of parturition. There's one slide in particular I want you to focus on out of your book. And then we're going to talk about lactational physiology. We're going to look at the core structures of the udder. We'll also look at different types of udder designs, and we'll also look at kind of the microanatomy of the mammary alveolus and talk a little bit about a lot of the stuff we're going to talk about today. Honestly, we've touched on already, particularly with the lactational physiology. So we're going to kind of put a bow around everything. At the end, we talk about parturition. We can break it down into three phases, and you kind of already know this. Moving the fetus into the cervix. We'll talk about what that means relative to stimulating contractions as we go through. Expulsion of the fetus, obviously, and then ultimately expulsion of the placenta. And we mentioned some of that last time relative to placentation. I want to ask you some questions on these and see if you can remember some of the stuff we talked about, particularly the hormones related to this. Rotation of birth position. What is the normal presentation for a single birth animal?
Usually feet first.
Diving
position.
Feet first, head in between. Okay. Now litter bearers, they can come in different directions and all that kind of stuff. There is a normal birth position, particularly those that are single birth. Pelvic expansion, are we going to see pelvic expansion associated with parturition?
Yes.
Okay, you say yes. Tell me about the hormonal effects on that. Pelvis is basically two, more or less, they're not totally fused, but bones, so the two sides of the pelvis. What holds them together? No, the raw ligament attaches to them. But you're right, there is a ligament. Don't pelvic ligament. What hormone allows that ligament to become loosened so the pelvic bones can actually move apart? Relaxin. And we'll talk about relaxin a good bit today because relative to parturition, we already mentioned we need a lot of things to be softened and stretching, right? We need the vulva to soften. We need those pelvic ligaments to be able to stretch. All that associated with allowing the fetus out. mucus streaming. Where is that coming from? Prior to parturition, in many females, we will see mucus that starts to string out of the vulva. Where did that mucus come from?
Mucus plug.
It's the mucus plug, but what has happened to the viscosity of the mucus plug? Mucus plug during pregnancy was very viscous, right? It was like a plug. But what happens is, and this is actually an estrogen effect, what happens is the mucus plug actually starts to soften and it starts to string out. So at that point, we've now opened up the cervix relative to that plug to obviously allow for the next step for cervical expansion. We've talked some about mammary gland stimulation. We'll talk a lot more about that today. Prolactin does what relative to the mammary glands?
Milk
Produces
production.
milk, and we'll look at where that happens specifically. And then what about oxytocin?
Milk letdown.
Milk letdown. Do you remember? This is a little thing we talked about. Do you remember we talked about oxytocin coming from the CL? Because normally oxytocin is coming from, or at least stored and released from the posterior lobe of the pituitary gland, right? Comes to the paraventricular nucleolus. But remember us talking about oxytocin is also produced by the CL?
Yeah.
When was that?
During
Right around parturition. Why was that occurring?
to have milk ready without stimulation.
Good. To have milk down there in the teats, so it would be there more or less dripping from the teats to allow that baby to learn how to actually drink. And nest building seclusion effects, what hormone is going to affect that? Talk about that. What? Do animals build nests? Do mammals build nests? We know birds do. Do mammals build nests?
Yes,
Yeah.
some.
Give me examples of mammals that build nests.
Deer.
Yeah. Yeah, pigs do. Somebody said squirrels, yeah. Dogs and cats. Beaver. There's a lot of mammals that do. What about cows? Ever thought about that?
Yeah.
I don't know if you call it a nest. They may tramp down an area or something like that, but what do we see relative to that in many species like cattle? We see them moving away from the herd with this, including themselves. Okay? And that's all about protecting nest building, and the seclusion is all about protecting the baby. What hormone controls those aspects? That nest building effect, prolactin does, because it's also affecting the brain, that maternal behavior. So there's some basic stuff. This is the particular slide that I want you to focus on today. This summarizes all of the physiology relative to parturition. So the question you have to ask yourself is, what starts parturition? Who starts parturition? You got two options, right? You got the dam and you got the fetus. Who starts it? You guys all about that? Who starts it?
Fetus?
The fetus does. Okay, the fetus actually starts the process. Obviously, you can see there we got fetus involved here somewhere. So what starts the process though? The fetus starts it. But why does the fetus start it? What stimulates that fetus to start the process? What happens when that uterus gets really full of fetus?
Pressure.
They get stressed. Crowding. They feel like it's closing in on them. They're running out of oxygen. Those two things cause stress. The fetus actually becomes stressed. And that's normal. Okay? But the stress effect on the fetus is what starts this entire process. The fetus produces that hormone right there. Do you recall what that hormone is?
Adrenocorticotropic hormone.
Adrenocorticotropic hormone. Where did that come from?
Anterior pituitary.
Anterior pituitary gland. And it affected what? Adrenocortico.
Adrenal glands.
The cortex of the adrenal glands to cause and produce cortisol, which is the stress hormone. So what happens in response to this crowding, this hypoxia is a fancy word for running out of oxygen, hypoxia. Those two things cause stress on the fetus. The fetus starts to produce in response to that more ACTH. That stimulates their adrenal glands to produce cortisol, which is the stress hormone. that right there is the key. That's the trigger that's going to start to stimulate this cascade of events occurring in the dam, is this high level of fetal cortisol. All of that is going to stimulate a bunch of stuff happening at the level of the placenta, at the level of the uterus, at the level of the CL. So let's take each one thing at a time. Fetal cortisol levels going up actually increases the production of enzymes. These are aromatizing enzymes that allow progesterone to be converted to estrogen. This is placental. Now we've kind of up to this point just kind of said, well, the CL produces all the progesterone during pregnancy. That's not exactly true. Towards the end of pregnancy, in most species, the placenta is actually producing a lot of the progesterone at that point. So what happens is, when parturition begins, that progesterone is being converted to estrogen. So interestingly, around parturition, we see an increasing level in estrogen, which you don't normally expect that, but that's going to be a key enzyme that starts the process of contraction. So the first thing that happens is this fetal cortisol stimulates the production of these enzymes that convert this placental progesterone to estrogen. So estrogen levels are going up. Keep that in mind for a second. In addition to that, we see a stimulation of the production of PGF2 alpha. Do you remember where that's going to be produced from? Now that production is being stimulated by that increasing level of fetal cortisol. But where does PGF2 alpha come from? The uterus. Okay, the uterus is going to produce that PGF2 alpha. So the two hormones we see going up during parturition are estrogen and PGF2 alpha, both of those in response to that increasing level of fetal cortisol. So the dam is starting to produce, this is a conversion effect, but the levels of estrogen is going up, and she's starting to produce PGF2 alpha from the uterus. Now we know about this, well, I'm not going to revisit all that. We know PGF2 alpha causes luteolysis, it causes regression of CL. At this point we don't need the CL anymore, so we can start regressing it. PGF2 alpha also causes an increase in production of relaxin from the CL and from the placenta. Both of those produce relaxin, and we know what it does. It causes softening of tissue, that stretching effects and all that. I want to really focus today on, relative to this, because this is not what we've talked about at this point, is this arrow here and this arrow here. Estrogen and PGF2 alpha's effect on the myometrium. Because we've got to start the contraction somewhere. But would it make sense if you've got this fetus in the uterus ready to come out, would it make any sense to have this massive, really super strong contraction take place all of a sudden? Why would that not make any sense? We eventually want that, right? We want massive contractions, but why would it not make any sense to have this boom, massive contraction all of a sudden out of the blue? Why would that make no sense?
Nothing else is ready.
Yeah, all kind of damage potential there, right? So we need to build up to that. And that's what estrogen and PGF2 alpha does. Because we know, and we've mentioned this already, that estrogen and PGF2 alpha can have a very mild effect on myometrial contraction. But it's not a strong effect. But it will cause a very low-level contraction of the myometrium. So if I'm a fetus in the uterus and I'm stressed and I'm producing fetal cortisol, and now the dam, if she's producing more estrogen or converting estrogen, producing PGF2 alpha, and those levels are going up, those are affecting the myometrium that's around me. But I'm not going to be dramatically pushed initially. What am I going to experience if I'm a fetus? I'm going to be like just a little shove, just a little push, just a little, mild. Because what are we trying to get to? I'm sitting like this. Where am I at this point? I'm still in the uterus, but I'm right behind the cervix. And now I need to start pushing on that cervix. So she's pushing from behind me, but mildly. So I'm the fetus, I'm pushing on the cervix. Push a little farther, push, push. What am I doing to the cervix? I'm touching it. I'm tactily stimulating that cervix. That's the key. When that fetus or multiple fetus starts to stimulate that cervix, that tactile stimulation sends a signal to the female's brain, ultimately, and to the paraventricular nuclei and then posterior lobe pituitary glands are released from there to cause this massive production of oxytocin at that point. And then what happens to that myometrium? When we get this massive production of oxytocin, if I'm a fetus, what's the issue there? I'm fixing to feel a big push from behind. Because remember, oxytocin has a really strong effect on smooth muscle. We know that. So the key, though, to understanding is the increasing level of estrogen and PGF2 alpha is causing a very mild push. And I'm a fetus, and I'm slowly being pushed, and I'm rubbing against that cervix, and I'm pushed a little farther and rubbed against that cervix, and that tactile stimulation of my paws or my hooves or whatever on that cervix is causing literally a stimulation of that whole oxytocin network effect we talked about to cause the production of oxytocin, a release of oxytocin, to cause a massive push that ultimately will expel the fetus. Does that make sense? The key to understanding it, though, in this cascade is it starts with a very mild myometrial contraction coming from increasing levels of estrogen and increasing levels of PGF2 alpha. Now, obviously, along with that, anytime we see estrogen levels going up anywhere relative to the reproductive tract, we're going to see increasing level of secretions. That's just what estrogen does. And that would make sense because we want to somewhat lubricate the cervix, the vestibule, and all that stuff to make it a little bit easier to push out the lubrication. But again, this is the most important thing relative to what's going on, because this is that cascade that ultimately leads to that massive contraction that will push the fetus out, and also along with that, push out the placenta afterwards. Does this make sense? Any of that stuff not make sense? Anything need to go back through any of that stuff? Okay.
If the fetus is in the wrong position and doesn't stimulate the cervix, could it potentially not cause the large contractions and cause issues with that?
Potentially, yeah.
Okay.
But usually when they're malpositioned, even that, it may not be as strong of a stimulation, but even that pushing up against that
pressure,
that lip of the cervix is enough to stimulate it. I mean, like their butt, their butt was pushing up, that would be enough to stimulate it.
Okay.
Anything else on this? Everybody good on that? Okay. Boom. What is that? What am I looking at?
Mammary.
Oh, I hear it's different words. What am I looking at?
Mammary system.
Of her mammary gland or mammary system. Now, is it just, back to the mammary, is it just the mammary gland?
No.
Is the mammary glands there?
Yeah.
Yes. Can we have successful milk production just having mammary glands?
No.
Oh, obviously not. We have to have a delivery mechanism. We have to have a support mechanism. So this would classically be called an udder. Y'all think y'all are going for a little bit more intense, aren't you? So what am I looking at here? And we'll look at more of the anatomy in a minute. Obviously the mammary glands are going to be in this area here, but we've got skin surrounding. Does skin support? Yes. Is it major? No, but it does support. Okay, obviously you have the teats here. We have another, we'll talk about this in a second, we have a fairly significant ligament support structure. Because we do obviously need to support these mammary glands, so that's part of this as well. We have teats here for delivery. Now, this is always a funny question to ask. This is a thought question. What animal is that from? Okay.
The angle you're looking at.
Goat. Very good.
I just don't, they have what, 2?
2, right? Normally, at least. Normally 2, right? So could it be a goat? Yeah, absolutely. Could it be a ewe?
Yeah.
No. Could it be a cow?
Could be if you just look in the back end.
It could be. It's deceiving, right? Because how many mammary glands does the cow have? 4. How many teats does the cow have? 4. Okay. You only see 2 teats there. I know you're like, okay, that's a little bit of a stretch. Well, bear with me. If she had a perfect udder, when I say perfect, I mean the teats are perfectly aligned with one another, and I was looking at her from behind, couldn't she have 4?
Yeah.
I just don't see the ones in front.
Yeah.
I know that's a little strange. That doesn't happen that often, but theoretically that could happen. But we would assume that this is probably something like a small ruminant that goes or used. But I want to key in here on these support structures. Because if support structures are important, if we don't have these or these support structures, and you might have seen animals like this before, the support structures are weakened, genetically weakened, aged weakened, what's going to happen?
Roots, bad conformation.
Right, they're going to have bad udder conformation. What is bad udder conformation?
Low between their legs.
Yeah, from the standpoint of milking the animals, that's obviously an issue, right? What about even if we had something like a beef cow that we don't milk?
It's too large. It could inhibit her walking and movement.
Okay, could affect her movement. Obviously, if we have major issues with, balloon teeth and all that kind of stuff, it may be hard for the calf to actually get milk out. What about if it's really pendulous and it's dragging the ground? Not dragging, that's excessive, but
bacteria.
Yeah, exactly. You can pick up bacteria. So obviously, udder conformation is important from the standpoint of being able to nurse, being able to produce safe product. Within this, there is a support structure, though, or a support network. Two types of ligaments, a median, which refers to middle, obviously, and a lateral, which refers to the outside area. You got median suspensory ligaments, you got lateral suspensory ligaments that hold it up. You also have these little sheet-like extensions called lamellae. That's what these little feather-like things are. They just dig in and give extra support, but they're extensions of those other ligaments. The question is, you've got two types of ligament here, a median and a lateral. Which one allows for expansion? Because one of these is elastic and one is not. Do we need them to be elastic?
Yes.
If one of them better be. Why? Because what happens during the day or when the animal is not nursing? The mammary gland is going to fill up. So it needs to be able to stretch some. One of these is elastic and one is not. The median, interestingly, is the elastic. The lateral is not. So when the mammary glands start to fill up with milk, the stretch effect is here. The median is the elastic one. The lateral is much less elastic. But these suspensory ligaments, along with the corresponding lamellae, are the important support structure for the mammary gland. The skin is minor. The skin is there. But the skin doesn't do the heavy lifting, no pun intended, when it comes to the mammary glands. Of course, the teats, we'll talk about the structure of the teats in just a minute. But this is specifically referring to the support network, or support structure for the mammary glands. Now, this is out of your book, but I think they do a terrible job on this in one respect, because it's confusing. So however you want to look at this, if it confuses you, mark through it, I don't care. I don't care about a camel. I mean, if you want to learn about camels, that's fine. I'm not concerned about camels. But if you look at this, they put camel picture and cow picture side by side with this diagram in the middle, or this figure in the middle. That to me looks confusing, because it seems to me they're saying this is the same as this and this is the same as that. That's not true. This line right here is connected to the cow. What they're trying to say is that a camel has 4 teats in between the legs, okay? And a cow does as well. That's what they're trying to do. So don't get that confused. I don't even care about this part up here at all. When it comes to the camel stuff, this is all camel stuff. I'm not going to ask you about camel stuff. If you want to learn about camel stuff, but it's just odd to me some of the animals that they're just these random animals. Which is fine, camels are great, whatever. And of course, in some countries, they're very important. Okay. Focus here. This is the cow down here. Here's small ruminants here. So note the lines to keep this straight. Okay. Let's first talk about, and this is common sense stuff. You already know this, but let's define the terms. What's the difference between inguinal and abdominal when we come to the location of the mammary glands? Inguinal versus abdominal. Inguinal typically is between the back legs, okay? And abdominal is what?
On the abdomen.
Along the abdomen. Usually we talk about animals with abdominal location as what type of animals?
Litter bearers.
Litter bearers. Okay, makes sense, right? So when we talk about the sow, when we talk about the bitch, talk about the queen, they're all abdominal. Okay, the rabbit, doe, all that stuff. Of course, those animals that do not have litters, per se, they are inguinal. So this would be an example of the smaller ones. The mares that have 2 teats, and this, of course, the cow having 4 teats, but they're between their back legs in the inguinal location. So let's take a look at the design here. I want you to key in. Now, don't freak out when I start to say these terms, because those terms are on another slide. So I want to go through this structure, though. This represents the mammary gland here. Okay, this weird looking little tree structure. That open area right there is called the gland cistern. A cistern is just an open space. So that's the gland cistern there. There's one gland cistern for every mammary gland. And then this open space in the teat is called the teat cistern. And then this open area of the actual teat where the milk comes out is called the teat meatus or streak canal. Again, don't worry, those terms are on the slide. I need to find those before we move on. So you've got the gland cistern here, the teat cistern here, open area again, and then you've got the teat meatus or streak canal where the milk actually comes out. Now, if you know anything about milking while we're on it, if you know anything about milking cows, or anything for that matter, if you look at this cross-sectional anatomy, it'll give you an idea why it's effective, or one way is effective and one way is not. If you know, man off the street, I say, come milk this cow, what's he going to do? If I can actually get him to touch the animal, what's he going to do?
Squeeze.
He's going to take and squeeze that and just pull straight down. Why does that not work? Look at that anatomy and it will tell you, because the milk is in here. The milk doesn't come out because there's a little sphincter right there. We have to push against that sphincter to allow the milk out. So when you milk by hand, or the machines do it basically the same way, what do? You
Roll.
more or less strip it, right?
Yeah.
So what you're doing is you're artificially closing off right there between the gland cistern and the teat cistern to increase the pressure here. The milk's in there and you're forcing it out. Does that make sense? So there is an anatomical design effect based on the way we milk animals. And again, you could do that with cows, or you do that with horses, or whatever, the same concept. So in the case of our small ruminants, now what I want you to know is ratios here. Ratios of mammary glands to teats, that kind of stuff. So keep that in mind as we go through this. So let's look at these animals collectively, the cow and the small ruminants. How many mammary glands do they have? Let's do that first. How many mammary glands does a cow have? 4. How many teats does a cow have? 4. So what is the mammary gland to teat ratio?
1:1.
1:1. That's easy, right? Okay, no big deal. Okay, let's do the small ruminants. How many teats does a small ruminant have? Sorry, how many mammary glands does a small ruminant have? 2. How many teats do they have? 2. What's the ratio of mammary glands to teat?
1:1.
1:1. So we've not changed. Just the number of mammary glands is the only difference. So that's why they're collectively lumped together. Now we come into some weirdos here. Yes, here's another example, just like we talked about placentation, where the horse and the sow are actually very similar. And it's the design of their mammary glands. This again is a mammary gland. You'll notice here though, what do we have? We actually have 2 mammary gland complexes together here. How do I know that? How do I know that's 2 mammary glands and not 1 mammary gland?
Not connected.
Because it has 2 gland cisterns. You always have 1 gland cistern per mammary gland. So there's a gland cistern there and a gland cistern there. There's a teat cistern there, a teat cistern there, and a teat meatus there, and a teat meatus there. So, having said that, and typically with these animals it's 2 or 3. Okay. How many mammary glands does a mare have? 4. How many teats does a mare have? 2. So what's the ratio of mammary glands to teats in the mare? 2 to 1. Okay, mammary glands to teats, 2 to 1. And if anybody's ever milked a mare before, which is not something you commonly do, by the way, because they don't react well to being milked like, say, a cow does. And sometimes they don't react very well. But if you do for research purposes or whatever, if you ever strip a mare, sometimes you'll see two streams of milk come out. Why is that? Because you've got 2 streak canals, or 2 teat meatus. Its design is the same as the sow other than her location. So how many mammary glands does a sow have? Yeah, depending on a ton of stuff, right? Let's just use that as an example. Because it's going to vary from sometimes animal to animal, certainly breed. 1, 2, 4, 6, 8, 10, 12, 14, 16. Okay. So she has 16 teats. So how many mammary glands do you have?
32.
At least 32.
Yeah, at least 32. Okay, at least 32. If it's a duplex. Okay. So it'd be a 2 to 1 ratio. It could be a 3 to 1 ratio depending on the animal. So it does vary some. Does that make sense? Again, the only difference is location between the design of these two. So you can have situations where you have more than one street canal or TPAtus, more than one gland cistern per teeth. Now this is an oddball, and why this is, I'm not totally sure. There may be a volume effect, because when it's designed like this, there's more volume that comes out in one suckling response. But why it's this way is unbeknownst to me. This is an example, again, of abdominal location. And again, I don't care, I mean, rats and mice, whatever, I'm good with it. A lot of our small animal species are designed like this. And when you ever see a bitch, if you ever see a bitch that has a litter, you'll notice her underline is really weird looking. I don't care if it's a really, really super good bitch. Her underline's weird looking, right?
Yeah.
I mean, it's like that. It's weird looking. Her teats are really wide, especially at the top. And it's because of the way it's designed. You have this weird complex where you may have 5 or 6, literally 5 or 6 mammary glands per teat. But they're really tiny mammary glands. But one thing we do know is you've got, for each one of these little mammary gland complexes, you've got individual gland cisterns, and individual TPAtus, and individual, individual teat cistern, individual TPAtus, for all that. So it creates this wide teat. It's a little bit different. So these are kind of the oddballs when it comes to this. So these animals are going to have 5 to 6 in that neighborhood mammary glands per teat. But they're very, very tiny mammary gland complexes. Okay, let's briefly look at it. And again, a lot of this we've already talked about in one aspect or another. This is kind of putting it all together. Let's look at the anatomy of the mammary alveolus. We know this is the basic functional unit of the mammary gland because this is where milk is made, and this is where milk letdown is initiated from. Go back, what hormone makes milk, or at least stimulates the making of milk?
Prolactin.
Prolactin. What hormone causes milk letdown? Oxytocin. So this is where those hormones are going to come into play. This is a little cross section, or at least an area taken out of this alveoli. They are these dead-end little spheres. Unlike the alveoli of your lungs, though, there's a lot of stuff going on inside of here. These alveoli are lined with epithelial cells. These epithelial cells are what make milk in response to prolactin. Okay, you can obviously see arterial blood flowing too to bring that the hormones and the nutrients to these alveoli, and venous blood taking the waste product, if you will, away. So a lot of blood flow to these. The epithelial cells line the inside of these alveoli. They are stimulated by prolactin. In response to that, they manufacture milk. Those alveoli fill up with milk. What has to happen, though, after they fill up with milk? Somehow that milk has to get out. And that's where oxytocin comes into play. We've mentioned it several times in here. We now look at it. What specific cells are stimulated by oxytocin in the mammary gland? Myomuscle epithelial cells. Don't confuse these now. Epithelial cells of the alveoli are inside. Myoepithelial cells are on the outside. They're these stringy looking cells here, all that line the outside or encompass and encircle the outside of the alveoli. And when those are stimulated by oxytocin, they contract. If there's milk inside that alveoli, what happens to it? It's pushed out into this duct network, and it goes from these tiny little ducts here to larger ducts, and ultimately down to the gland cistern, and then TPAtus and out. Okay. Does that make sense? So prolactin is affecting the epithelial cells inside of the alveoli to make milk. Oxytocin is affecting the myoepithelial cells on the outside to contract, to push that milk out of these alveoli down into the duct system and ultimately out. So you've got to have manufactured milk coupled with milk letdown. If you have one without the other, you're not going to have successful lactation, obviously. Does that make sense? This is pretty simple. We've kind of touched on a lot of this already. Now the last slide is kind of putting it all together relative to milk letdown process. Here's your terms that we already mentioned. Gland cistern here. This is the mammary gland broken up into these lobes. Gland cistern here, teat cistern here, teat meatus there, and that's referring to that teat sphincter there that kind of keeps the milk from running out until we want it to. This shows the oxytocin effect. What normally, that's a loose term to use, what normally causes milk letdown? What normally causes it? What kind of stimulation? Tactile stimulation, typically by what? Right, nursing activity. Okay. The babies, whatever. What are they doing? You know this. What do they do? They're starting to suckle. They hit. You've seen goat kids, right? They like to grab and hit. They're like, oh, that's cool. There's a reason behind the fact they hit her udder, because it's like, give me more, because it's actually a tactile stimulation. So this is designed. The key there is designed for natural stimulation from a suckling effect, tactile stimulation by the offspring on the dam's udder to send a signal ultimately through the central nervous system to the brain, to the paraventricular nuclei, to manufacture oxytocin and release from the posterior lobe, back into systemic circulation, that's what that red is, and then ultimately down to the mammary glands to affect the myoepithelial cells called milk letdown. Okay? That's the way it works. Is that the same way it works if I go out to a dairy today and watch them milk cows? Is this same thing here going on? Well, yes, because we have oxytocin effect. But are we taking, most of you know the answer to this question, are we taking a calf? We got my cows coming in, we take a calf and stick it up there.
Yep.
No, I know that. Okay. What do we do? What, are we still having a suckling effect? No. What, though, are we doing to stimulate milk letdown?
Stripping.
We're touching somehow. Right? In preparation for milking, what are you going to do? She said stripping, right? You're touching the teats. Okay? You might be wiping off the teats, cleaning, whatever. You are tactily stimulating. That causes milk letdown. Oh, but can milk letdown be conditioned?
Yes.
In commercial dairy herds, we see it all the time. And it actually probably is a good thing. Because we can see animals that are already letting their milk down as they're walking into a milking parlor. Why do they do that? Because they are conditioned to do it. There may be smells, there may be sound, music, those type of things that actually condition them to start letting their milk down. Okay? And that helps us because we don't need, you're still going to clean and strip and all that stuff, but you don't necessarily need that as much. So they can become conditioned. But ultimately, though, the way this should work is some sort of tactile stimulation at the level of the udder to send a signal up to the brain, to the paraventricular nuclei, to the posterior lobe to release it from there, oxytocin into systemic circulation, make its way back down. This is kind of a cool little diagram to show what we've already mentioned on the last slide. Here is the alveoli here, alveoli here. Notice this is kind of, you can see, look, little white lines. That represents prolactin causing the manufacture of milk by those epithelial cells. And then look right there. There's actually milk in there. Isn't that cool? See the milk? Mm-hmm. Oh, so it's kind of cool. What has happened here, though? Why is the milk here?
It travels down the ducts.
Oxytocin.
What caused the milk to be right there? We made it right there. What happened here?
Contractions caused by oxytocin.
Myoepithelial cells were stimulated by oxytocin to contract, squeeze those alveoli out into the ducts, and now the milk's going out. Okay. And you can see, if you look at those little thin lines right there, there's a dot right there, those little thin lines, that represents the myoepithelial cells surrounding the alveoli. So this actually shows you a little bit more anatomically correct than the last diagram did. So this is milk manufactured here by this epithelial cell, and this shows the process of milk let down here into those cells. Questions at all on any of that? Just
Is there a difference in the amount of oxytocin that's signaling the milk let down? What's a dairy? I've only seen it at one last summer, and they actually gave their shots every milk, and they were given a shot of oxytocin to their animals. Or is that just a waste of time?
That's a I don't want to say it's a touchy subject, but I've heard several examples of that. I think that is I think it's a waste of money to do that. What happens though, oftentimes, is those, because you talk to some people like that and they will say, well, if I don't give it, they don't milk as much. But yeah, because the animals are now
Used to getting that.
they're not conditioned the wrong word, but now they are physiologically used to getting exogenous oxytocin, so they demand it because their body's basically saying, I don't need to make it. So they stop using it, and then their milk production goes down.
Like the same with people taking testosterone.
Yeah, exactly. So it's to me, it's my personal opinion, it's a bad practice to start. I mean, I don't know if you just started exogenous oxytocin, and number one, that's kind of expensive anyway. If you just started that out of the blue, the question is, and I don't know the answer, I don't know enough about dairy production, but does exogenous oxytocin give you enough increase in milk production to justify it? And I don't know if it does or not. But I've heard of there's a number of dairies that actually do that. I just think even beyond that, I think just from an animal handling standpoint, and like how you gotta give an injection to all these cows every day or twice a day or whatever, costs a lot of money too. But they will, if you stop it, their milk production will drop bad, and they'll be like, well, no, look at their milk production. Well, physiologically, there's a reason, because their body say, well, I don't need to make it. So if they don't make it, then milk production will go down.
How would you give that? Like, would that be sub-Q or?
I think oxytocin is intramuscular, isn't it?
Yeah, they were just sticking it right in her leg twice a day.
Would that have an effect on those muscles at all then?
I don't know.
Yeah, would that be like in the milk?
Well, oxytocin is going to be in the milk anyway. So it's, I mean, there's
Would it
always
be like
some. I don't know. There's certainly be it was, it's kind of funny because we don't do this anymore, but probably 15 years ago, it was pretty common practice to use BST, which bovine somatotropin, because it actually increases milk production to a certain extent. And of course, you would find that in milk anyway. They did research, and exogenous BST didn't increase substantially any BST that was already in the milk. It was there naturally anyway. But the economy of that didn't make sense, and there was a lot of pushback from consumers because of. If you ever look at milk now, almost every milk you buy, any brand, it'll have a statement. We haven't used BST in a long time, but it'll have a statement that says these cows have not been treated with BST.
Yeah, I like to know whatever.
Yeah, that was a pretty bad pushback from consumers when they found out you were giving them growth hormone, which it is growth hormone, but it didn't affect the amount in the milk. It was still going to be some there.
Yeah.
Not to mention it's bovine growth hormone.
Yeah.
It's going to have an effect on people.
Yeah, but I mean, that was the whole. I don't get so long, but that was back in the day when it's like, well, you're drinking milk and it's causing girls to mature when they're 5 years old to go through puberty and all this stuff. I'm like, no, that's not the reason. The main, you can say, well, why is puberty increased? The age of puberty decreased, basically. It wasn't because of drinking milk.
Body fat.
Exactly. It was because in America, the obesity rate is going up a lot. So we talked about it here, right? A lot of stored body fat. What does it signal? Say, hey, I'm young. I got a lot of stored body fat. I can start reproducing earlier. So that's why. But agriculture gets blamed, unfortunately. My world, I get blamed for. Chicken people are the devil sometimes because we just pump them off with hormones every day, thousands and thousands.
No, they're just naturally selected to be.
Do what?
They're naturally selected to be that big. Right?
Yeah, I know. That's always. It's funny. We're starting this 4-H FFA broiler program starting later in the fall, and I had a mother that emailed me a couple of days ago, and I did. I mean, I was nice about it and all, but and tried to make her aware. But she was interested in the program. It's where kids get 20 broiler chicks and they raise them and show them and all that stuff. And but she was interested and she was excited about it. She said she had a couple questions. Her first question was, were they genetically modified? And I was like, wow, that's where we're at. But and then I explained to her, that they're not genetically modified organisms. We've done a lot of selective breeding over the last 50 years in poultry industry and all that stuff. Maybe I teased her, I don't know, but that's where we're at. I mean, that's what you're here for. You are here for agricultural awareness to the public. So go from here and educate the uneducated.
So, what's your opinion on? You know how when you go to Kroger or whatever, you go to the egg section, then you're in your white eggs, and
What now? Back up.
Like when you go to the store and you're in the egg section,
The
you
egg
have your
section.
white eggs, and then you have your brown omega eggs that have all these vitamins in it. Do they really have vitamins in it, or do they just say they have vitamins in it?
Yeah, you got to be careful on some of that. Eggs are interesting now because the marketing is there, but there's so much variability now. If I take Kroger brand, or whatever brand, your Publix brand, whatever, white eggs, and Kroger brand brown eggs. No added, no free range, no apples to apples, basically, except for color. There's nothing different. There is nothing from the standpoint of nutrient content different in those eggs. The only thing different is the color of the shell. People are like, well, why do these brown eggs cost more? Well, because the birds that lay those are bigger birds, and they have a higher maintenance requirement. We have to feed them more. It costs more. Now, to your point, though, you see these Eggland's Best, some of these others, even Kroger's got a brand of.
Yeah, there's like a brown Omega egg, it's like B12 ounces in it.
Yeah, now those are somewhat legitimate because they're expensive for a reason, because we modify. That's the one thing that's great about chickens is that we can, from a standpoint of consumer, we can modify the content of the yolk very easily in what we feed the bird. We can modify the color. You want to have a red yolk? Take away corn, put white corn in there, and put a bunch of red pigment or red food coloring in there, and you'll turn your yolks red. So it's very easy to modify what's in the yolk. Those birds, Eggland's Best and all those Omega, we just are feeding them a diet with a lot of flaxseed in it and that kind of stuff that actually they do deposit a lot in there. So there is something there. The free range thing, if that makes you feel better and all that, that's great. But as far as content of nutrients, there's no difference there when it comes to that. So some of that you got to be a little careful about. When it comes to those that are labeled a little bit more vitamins, omega-3s and all that stuff, that's more legitimate because we actually feed them that.
Okay, that was what I was wondering. I don't know if it was kind of like just their branding, like if it was a lie or they actually do have that.
No, that's legitimate. I don't buy them because I'm cheap, but every now and then I'll be let me treat myself and buy Eggland's Best, and I like them because they do have a more intense flavor. Their yolk does because of but they're way expensive.
That's what I get that, but I'm like,
Yeah.
I'm not sure at all. So.
No, you're really not on those because we can modify them. It's a good one. Anything else?
Do you want us to start
What is in the sheet?
or just ready? You talked about.
You got to do your thing though.